Hello student, how are you? I hope you are will be fine. I'm also fine, thank you. How is the day going? It is very fine here. Thank you. Okay, let's start today lecture. Today is the lecture number 15 of crystal field theory. Today is today we will discuss one of the application of crystal field theory is that how due to crystal field theory how the transition, how the complexes show transition or how the complexes show colors. So we will discuss in today's topic is color of transition and different metal complexes or what is the factor that depend upon the color of the complexes. So you can say that how crystal field theory explain the color of the complexes. So let's start today's topic. And today's topic, first, you know that when white light is coming from the sunlight, when white light is coming from the sunlight, when it reflect uh, when it fall on any surface, after falling from a surface, if it reflects, the surface reflects some light, the surface reflects some light, some portion of light. This light will show us the color of the surface. Similarly, when white light come from the sunlight, when white light fall on the metal complex, any metal complex, after falling the complex absorbs some light, some portion of the light. Complex absorbs some portion of the light. After the absorption of some portion of the light, the remaining light are the complementary color. Every portion of light has some complementary color. Every portion of light has the color that show after the absorption. When the complex absorbs some lights, the complementary color, the color that show us to the given complex, that color will call complementary color. So the absorption color we call absorbed color, while the reflected color called complementary color. So this absorption, the complementary color of this absorbed light will be show us, and that will be the uh, color of the given complex, color of the complex. So why show the complex color? What happened in the complex that they show the color? Okay, let's start today lecture. In today lecture we have studied why show the complexes colors. When the white light when the white light come from when the white light come from sunlight, when it fall on any surface, after falling surface, they absorb some light, the surface absorbs some portion of light, some absorb some portion of light. The complementary color of this absorbed light, the complementary color of this absorbed light will reflected, and this reflection will show us the color of the surface. Yeah, this reflection will show the color of the surface. What happened in the complex, when white light, let's suppose that is the complex, the surface complex, when white light fall on the complex, it absorbs some portion of light. After that, the complementary color of that absorbed light will reflected by the complex. So this reflection or this complementary color will show us the color of the given complex, or the you can say that the given complex will show that complementary color, that is the complementary color of the absorbed light. So what is phenomena, what is behind reason that why the complex absorb color? The reason is that, let's take the correct position of the camera. Okay, let's suppose this is the one metal, this 5 degenerate orbital. When there is splitting occur, like in octahedral complex, the T2G has lower in energy while EG has higher energy. Let's suppose if there is any electron in the system, let's suppose there is one electron. Let's suppose in T system there is in T2G there is one electron. When white light come, it have contain different photons, different having different frequencies, having different wavelength. So when the when the white light or when the photon fall on this electron, the electron will get energy. After getting the energy, when it gets sufficient energy, sufficient amount of energy, it will excited, it will go to the EG section, to the EG section. When this go to the EG section, there are different color, there are seven different lights of white light. There are different seven colors of white light are coming. When some portion of the white light are absorbed by the electron will go into the excited state, while the remaining electron, while the remaining colors and which the complementary color will show the color of this transition metal atom, because some of portion of light are absorbed due to transition occur. And this is the transition from one set of d orbital to another set of d orbital. That's why this transition is called dd transition. Also you can say that today topic is dd transition, or you can say dd transition. Okay, okay, it is called dd transition. So let's proceed the topic. Sorry. Now I'm showing just technique. So when the complex absorb the light of different wavelength, the color of the absorbed light, color of the absorbed light, wavelength of the absorbed light, wavelength of the absorbed light, color of the transition, color of the transmitted light, transmitted light, color of the transmitted light. So let's see. If the complex absorb violet color, but the range of violet color is this, and the wavelength will be in angstrom, in angstrom. So the violet color have 4000, from 4000 angstrom to 45,000 angstrom. That is the wavelength of color. So it will transmit the complementary color of violet is yellow green. The complementary color of violet is yellow green. The when the complex absorb blue color, its wavelength is 4500 to 4800, while its complementary color is yellow. When complex absorb green blue color, its frequency, its wavelength is 48, from 4800 to 4900. It is the complementary color of that light is orange color. When the complex absorb blue green color, first green blue, second blue green, its wavelength is for 900 to 5000. Its emitted red light, because red is the complementary color of blue green. When the when any complex absorb green color, its frequency, the wavelength of green color is from 5000 to 5600. So its transmitted color or its complementary color is red. Sorry, not red, it's violet. Yeah, right, violet. When the complementary color absorb yellow green color, its wavelength is from 506, from 5600 angstrom to 500 5800 angstrom, while its complementary color is also violet. but it is pink, dark pink. Yeah, not sorry, it is not pink. It is this one is like purple. Sorry. When the absorbed light, when the any complex absorbed light, yellow light, while its frequency is from 58,000 to 509,000, while its complementary color is blue. When any complex absorb orange light, when any complex absorb orange light, its complement its wavelength range is from 5,900 angstrom to 6,050 angstrom, while its complementary color is green blue. When the color of the transition, when any complex absorb red color, while its frequency is from 6,050 to 7,500 angstrom, while its complementary color is blue green. So this is the, when any complex, you can also take screenshot, you should need to remember these points. Blue color will have yellow green. The complement color of blue is yellow. You can also remember the technique from this point. If you draw any circle and you draw any 3 diameter, yeah, like that. So according to the formula called web gear, VIBGYOR, this is the formula. Having the white light contains these 7 color: red, orange, yellow, green, blue, indigo, violet, but here is missing indigo. This concept has been given in the books called G.M. Mizler books. G.M. Mizler book, Inorganic Chemistry by G.M. Mizler book. This concept is given in this book. So here from started violet, blue, green, yellow, orange, red. You can take the concept from this point. When any color, when any complex absorb violet light, when it absorb violet light, while its complementary color will be near to yellow, so it will be yellow green. When the complex absorb blue light, its complementary color will be yellow, it is near to orange. So while green blue is near to orange. So like where blue green is to red, while green is violet. So you can take concept from this point. You can take it, you can learn it by heart from this graph, from this table. Okay, is it clear? These are the absorbed light as well as the transmitted light. So is it clear? You can take screenshot now. I'm just cleaning the board because lack of space. Okay, thank you. So let's start. Origin of color. How color is originated, I already told you. Let's suppose this is the 5 degenerate orbital of d orbitals. If this splitting occur in like octahedral complex, what will happen? This is T2G, this is EG. Let's suppose if in T2G there is any electron, let's suppose there is 2 electron, when white light come and fall on the metal complex, the one electron will absorb some portion of the light. When it will excited, it will gain energy and excited to EG orbital, the electron will be go here. That will be like that. That will be like that. Splitting will be like that. The one electron will be like here remain, and one electron will be go into there. So when electron go here, it will um, it will absorb some light. So the light that absorb, the portion of the light that absorb, the complementary color that I told you before, the complementary color of this absorbed light will show the color of the complex, will show the color of the complex. Is it clear? Here this is And this is also the part of d orbital, this is also the set of d orbital, this is also the set of d orbital. So it is transition occur from d to d orbital, that's why it is called dd transition. This is called dd transition, is it right? So this is the origin of the color. So and now the color of the complex also depend upon a different factors. So let's start to explain these factors. And there are many factors that color of the complexity depend upon that factor. So let's start one by one. The first factor is, here is factor affecting color of the complex, affecting color of the complex. These factors are, number first factor is nature of the nature of central metal atom. Nature of central metal atom, what that mean? The central metal atom, different central metal atom will also show different color, different absorbed color, also show different emitted color, also show different the central metal atom, when two complexes having same ligands, that show that will show that will show different colors, because of central metal atom. Say, let for example, when there is chromium H2O 6 6 same ligand plus 2 ion, it absorb, it emit, it show us blue color, it show us blue color, this is the emitted color, emitted color. So while the complementary color, as I told you before, the complementary color of blue is yellow, so yellow will be absorbed, yellow will be absorbed. But in case of MnH2O6, same ligand plus 2 plus, sorry, plus 3. Now, let's suppose this this is plus 2. So that this complex experimentally show that's violet color, emitted violet color. So the complementary color of violet is the yellow green, yellow green. It means that sun color of the transition atom, or dd transition, also depend upon the nature of the central metal atom. Different central metal atom will have different absorbed color, also different emitted color. Is that clear? This is the first factor. While another factor is the nature of ligand. Nature of ligand also depend upon the central metal atom, also color of the complex also depend upon the nature of the ligands, nature of the ligands. Is it clear? So when all the things are same, only when all the conditions are same, only colors are different, only ligands are different, then what will be happen? Like in NiH2O6, H2O6 plus 2 ion, here is the emitted color, the color of this complex is the blue green, blue green. This is absorbed color. Well, blue green, this is this is the color of the complex, so its complementary color, this complex will be, this complex should be absorbed red color. The complementary color of blue green is red. While when in case of NiH2 Na3, Na3 which is strongly greater than H2O hexaamine plus 2 ion, in this case the complement the this complex will have blue color, will have blue color. So this complex blue is the complementary color, the complementary color of blue is yellow. So as you can see that, you can see clearly that the different ligands also affect also have effect on the complex's color. Different ligand will have different color, and also different central metal atom will have different color. You can take screenshot. I am just going to remove the to clean the board to further proceed. Color of transition complexes or dd transition also depend upon the oxidation state, oxidation state of the central metal atom. How? Let's take an example. Here is vanadium H2O6. If this vanadium has plus 3 charge, if this vanadium, in case of this complex, if this is plus 3 charge, at this there the color of this complex is the green blue, while we know that the absorbed color or the complementary color of green blue is orange. While in case of vanadium plus 2 H2O6, all the other thing are same, only the d system are different, and there are plus 2. So this complex have violet color, and we know that the violet is the complementary of violet color is yellow green. So this means that oxidation state has also effect on the color of the complexes. A different oxidation state will have different colors. Is it clear? These all are about today lecture. I hope you are will be clear. uh, these are only three factors. Okay, thank you. Goodbye, best of luck. Also subscribe my channel, please. It make me happy to saw that my students are supporting me. Okay, thank you. Please, if you have any question, if you have any problem, please comment me, ask me in comment section. Also you can ask me in my personal WhatsApp, as well as in my personal Gmail, as I drop in the description box. Okay, thank you.